for question 3.11 about recursion to loops, we must look at, if we look here at this slide, this is figure 3.1 from the book, it would be on page 48. This is an, a description of the GCD, the greatest common denominator function, written in an imperative version using a loop and a functional version with recursion. So if we look at the question here, it says, okay, it says, describe a general pattern for turning an almost tail recursive function into a loop in the same way that tail function recursive function can be transformed as described in section 3-1. So this is the description. So essentially how these are related are both of them have the same parameters. We have u and v, and in this case x's, so that you can modify the value outside the function, so that's not as important. And so we have these variables, they're assigned to whatever's passed in, same way that these variables are going to be passed into this function. These are going to be passed into this function. So here's where the actual loop takes place. So the condition for this loop is when y is not equal to 0. So as long as y is a value that's not 0, we want it to make t equal to y, do the modulus division, and then z equals t. So that's essentially a way of changing the values around to make it so that, so that you can perform the find the greatest common denominator once this loop is finished executing. And so if we look over at the functional version, we can see the pattern for how it was done. Same parameters. So we have a base case, which is what we need in order to stop the loop. This is essentially the condition. If v equals 0, return the value u. Is the same as saying while y is not 0, keep going. So it's saying stop when it's 0, this is saying stop when it's 0, and then it's returning this value, which, because they're different letters, is the same thing as u, essentially. And then otherwise, so as do this when it hasn't stopped, return, call it again, v, and u mod v. So it's going to do the modulus division with v as the parameter that's being passed in. So now u becomes v in the same way that t equals y and z equals t, and the answer, which is y, goes in as v. So it's going to go through, and if v equals 0, it's going to return u. So it's going to keep going through until it calls the greatest common denominator of 0. Something, or well, not 0, of something and then 0 here. Because if 0 is the second value, then it must be the greatest common denominator, because anything with 0 as the second value passed in is going to be the greatest common denominator. So you can see here, that's how these two versions of the same function perform the same task, but this does it, but because this is functional, it does it through recursion rather than through a loop.